I think we are discussing STP right now, if I'm not wrong.
Yes.
Right, Sachin?
Yes, sir.
So in previous class, I think in yesterday class, I told you what is STP and why we need STP, right?
Yes. Yes, right.
Because of loop avoidance, right
Yes.
now?
Yes.
Okay. So today we are starting the next terms here in STP. Yes. Let's suppose, first of all, if we have a team, fine. Let's suppose in a team there are multiple team members. Tell me yes or no. Yes.
Yes.
If there are multiple team members in a team, so definitely we need a team leader.
Yes.
Why we need a team leader? Why we need team leader actually? Because let's suppose if I, sorry, and you both are at the same designation, there is a 100% chance at any time there is a conflict on any topic.
Conflict. Yes.
On any
Maybe.
topic, yes, this is very common. There is a conflict. Fine. So if there is any conflict, then we need a leader, right? Where I go, you go, and this leader will responsible to resolve my problem and your problem. Tell me yes or no. Yes, na? So similarly in case of STP, if we have a topology and in this topology, if there are multiple switches, fine. So there is one leader. There is one leader. What is the name of that leader, guys? According
That
to
is
the
called
networking
STP.
language, that is called root bridge. That is called root bridge. Clear? Understand? Now, let's suppose if we have topology like this, A, B, C, D. Let's suppose all the switches are connected like this. All the switches is connected like this. Clear na? Tell me. Yes na?
Yes.
So
Yes.
in yesterday class, I told you, see na, see this topology. In this topology, all the switches are in loop. Tell me yes or
Yes.
no.
Yes.
Yes na? Okay. So if these all the switches are in loop, so basically now all the four switches, switch A, B, C, D, what all the four switches will do? All the four switches will perform the election. Perform the election.
Yes.
And on the basis of that election, all the four switches will elect one leader. And what is the name of that leader, guys? Root bridge. On the basis of that election, what they elect? They elect root bridge. Tell me, understand now?
Yes.
And let's suppose in this scenario, switch number A is a leader. Fine, elected as a leader. So switch number A is called root bridge. Guys, I am writing RB. RB means root bridge. Okay. So don't be confused.
Okay.
So switch A is called root bridge. Fine. And all the
Yes.
remaining switches, switch B, C, D is known as non-root bridge. Non-root bridge. Clear? Everyone?
Yes.
Are you tell me yes, na? Now.
Yes, sir. Yes.
So this is the root bridge and these are the non-root bridge. Fine na? So now, see, try to understand the rest switches, which is non-root bridge. Now what non-root bridge will do? Basically, now non-root bridge, it means switch number B, C, D will try to reach and try to find the shortest path to reach the root bridge. Try to find the shortest path to reach the root bridge.
Good.
For example, B. See now, B can reach the root bridge how many way? B can reach like this, B can reach like this, and B can reach like this.
Three way.
Right now? But what is
What is
the
the shortest
shortest
path?
path? This one?
Shortest path B 2A.
This one, na?
Yes.
Similarly, in case of C, C can reach the root bridge like this. Are you tell me yes or
Yes.
no?
Yes. Yes.
Now in case of D, D can reach the switch number A. It means its leader either like this or either like this. Tell me yes or no. Are you tell me?
Yes. Yes. There are two paths. And two
There
are
are
same.
two ways, na?
Both are
There
same.
are two ways. Either D can reach Y B or either D can reach Y C.
C.
Are
Yes.
clear na? So let's suppose D is reaching switch number A. It means its leader. Let's suppose Y this link. Y this link. So by the help of STP, if you remember in yesterday class, I told you what STP will do. STP just make alternate path as in the blocking state. Right now, I told you. So let's suppose this one and this one, these two links will be in which state, guys? Blocking state. What is blocking state? We will discuss later. But for your information, I just tell you, let's suppose if this link and this link in the blocking state, then there will be a no loop. Right now. But let's suppose if this link will not in the blocking state, then switch number D forward the packet like this and switch number D forward the packet like this. It means switch number A receive the same packet on this interface as well as on this interface, and this is called
Collision.
loop.
Loop.
So to avoid the loop, what STP will do? STP make this link as a blocking and this link as a blocking. So finally, now D can reach the A like this only, B can reach like this only, and C can reach like this only. There is a no loop. There is no problem. Are tell me yes or no? Clear na? Clear? Everyone.
Yes, sir.
So
Yes.
that's the reason I told you these are the non-root bridge. So all the non-root bridge try to find the best path to reach the root bridge. All the non-root bridge switch will try to find the best path to reach the root bridge.
Loop.
Let's suppose if we are working in the team and if we have a team leader, everyone wants not to good relationship with the team leader. Tell me yes or no.
Yes.
Similarly here, all the non-root bridge switch will try to find the best path to reach the root bridge, and let's suppose switch number D find this path is the best path and this is the alternate path, and by the help of STP this alternate path will be in which state? Let's suppose blocking state.
Okay.
Fine. So in primary case, switch number D will try to reach switch number A by this link, and by this way we can avoid the loop.
Yes.
I hope everyone understand till now. Clear? Now, in STP,
Please,
we are
please,
using some.
sir. Uh,
Yes.
One thing I want to ask, I want to know about election.
Yes, what
First-
is
first.
election and how election will perform? Yes, definitely we will discuss it. Okay. So basically, right now I'm just giving the types of introduction here. Okay, so please wait. Definitely we will discuss the election part as well.
Okay, sir.
Fine. How election will perform, how many criteria during the elections, everything we will discuss.
Okay.
Fine. Any doubt, Sachin?
No, sir. Till now.
Clear na?
Yes, sir.
Puna,
Clear.
are you there?
Yeah, I'm here.
I hope you understand.
Yeah, to a point, yes.
Okay. Now, guys, basically in case of STP, there are some terms. Some terms which we are using in STP. What are those terms? First is you see root bridge. And what is root bridge? I told you. Tell me yes or no. Yes. Now, non-root bridge. I hope you guys understand now what is root bridge and what is non-root bridge. Root bridge means if we have a topology where multiple paths to reach each other, right now. So in this case, we need one team leader, fine na, and one leader that is called root bridge. In this example, na, see na, let's suppose here, see in this example, for example, switch number B. It means in this example, if you see very carefully, every device can reach each device by two ways, at least two ways. Tell me your yes or no.
Yes,
Let's
yes.
suppose if switch number B wants to communicate with the switch number C, how many ways? 1, 2, 3. Tell me yes or no. Yes.
Yes, yes.
if switch number C wants to reach D, how many way? 1, 2, 3.
Three way.
So there are multiple ways through which switch can reach each other. Fine. So in this case, there will be loop. There will be loop. So how can you avoid? We can avoid the loop by electing one team leader, or you can say one boss. And what is the name of that boss, guys? Root bridge.
Yes.
Fine. And all the remaining switches is called non-root bridge. Fine. Clear? Third terms in STP, guys, port type. Third terms are port types. In some book you see port type, in some book you see port role. So don't be confused. Fine. Port type and port role. Fine. So basically now there are three types of port role or port type in STP. First of all, just write down, and what is these types we will discuss it later. Fine. First is DP. DP is known as designated port. RP, and the third one is, guys, block. So basically these are the port type and these are the port role in STP. Fine. And what is this? We will discuss it later. Fine. Clear, everyone? 4. Port terms which we will discuss in the STP, that is called port states. What is port states? There are 5 states in STP. First is disable. Second is blocking. Listening. Learning. And forwarding. I hope you guys aware about these port state, because you know na, when you power on the switch it takes 30 seconds to up. I think if you guys are working, definitely you guys know.
Yes.
Right now it takes generally 30 seconds. Why? Because of the port state. Because of the port states. Clear, everyone? Tell me.
Yes, sir. Sir, I am writing here.
You are writing?
Yes, sir.
You please write them. So basically, guys, these are the terms which we are going to study in the STP section. Fine? Clear? Sachin, do one thing, na? You can take a snapshot. This is the better way.
Yes, sir.
Clear?
Yes, sir. Taken.
Okay. Now, Sachin asked me the question, how election will perform. So our topic is, guys, election. Election of what? Election of root bridge. Election of root bridge. Clear na? Everyone, tell me. Are tell me yes, no.
Yes, yes.
Yeah, guys, you guys are my energy. If you guys are not responding, my energy will goes down. Fine. I am taking back-to-back batches. This is my third batches I am taking continuously. I am talking, and since I think 3 hours, 3 to 4 hours.
Oh,
Switch A, switch B. Let's suppose MAC address of switch number A is Gona. I hope you are also understanding. There is no problem, right?
Yeah, I'm understanding. मैंने 2 क्लास अटेंड नहीं किया था, but I'm trying to follow.
Okay, you understand Hindi as well. No worries. Very good. ओके, नो वरीज. आपने कोई अटेंड नहीं किया ना, डेफिनेटली आप वीडियो एक बार वॉच करोगे, डेफिनेटली आप अंडरस्टैंड कर जाओगे. हमने बहुत ग्राउंड लेवल से स्टार्ट किया है.
जी.
राइट सचिन, हमने जब से स्टार्ट किया है, आई थिंक हमने बहुत ही ग्राउंड लेवल से स्टार्ट किया है.
yes,
राइट
sir.
ना?
Exactly.
एंड आई होप कि जब से मैंने स्टार्ट किया है, ऐसा तो नहीं है कि आपको कुछ समझ में ना आ रहा हो.
नहीं आ रहा है. आज का 6वां दिन है, मैं कर रहा हूँ.
Cool. Now we are discussing about the election. Guys, first of all, tell me, let's suppose I am a candidate and you are also candidate, and if we both are participating in 2024 election in India. So definitely, na, who will win? It will decide on the basis of what? Vote. Tell me yes or no.
Yes.
So
Election.
it means between two parties or between two things, winner will elect or winner will decide on the basis of vote. Fine. Similarly, here, if we are performing the election between switch number A and switch number B, definitely there is some parameter. अरे tell me, yes ना कुछ parameter होंगे. Tell me.
Yeah. Yes.
So if we are performing the election between switch number A and switch number B, definitely there is some parameter. Fine. In case of STP. Fine. So basically, in case of STP, the parameter, or you can say the criteria on which election will perform, that is known as bridge ID. That is called, guys, bridge ID. So what is bridge ID? Bridge ID is the criteria of election, or you can say election criteria. On the basis of bridge ID, our root bridge will elect. Fine. Now, I just tell you something about the bridge ID as well. Basically, bridge ID, size of bridge ID is 8 byte. Size of bridge ID is 8 byte. And bridge ID is made up of two things. First is priority, and second one is MAC address. Priority plus MAC address. Size of priority is 2 byte. Size of MAC address is 8 byte. Priority range is 0 to 65,535. This is the priority range. Fine. And this is the MAC address. Clear? Understand?
Yes.
Tell me.
Yes.
Now, one more thing. By default, priority on every switches will be 32768. What is, guys? This is by default. By default, priority will be 32768. Clear? Understand? So I just tell you something about the bridge ID. So what is the conclusion? Conclusion is between switch number A and switch number B, we will elect the root bridge, and root bridge will elect on the basis of some parameter, and the name of that parameter is bridge ID. Clear? Understand? Now, one note. Here I am writing the note number 1. You guys can write this note. This is also very important. The switch whose bridge ID will be smallest, that switch will become root bridge. What I write, guys?
What?
The switch whose bridge ID will be smallest, that switch will become the root bridge. Understand, everyone? Written? Now. Are tell me, written now?
No, smallest will be become root.
Root bridge, RB.
Okay.
If you guys are written, then can I close this one?
Smallest bridge ID.
Yes, smallest bridge ID will prefer always. So smallest bridge ID will be the root bridge. The switch whose bridge ID will be smallest. Written?
Okay.
Okay. I am closing this now then. Wait. Okay. Okay. So switch number 1 whose MAC address is A and switch number B whose MAC address is B. Clear na everyone? Now, I told you on the basis of bridge ID, on the basis of bridge ID, switch number 1 and switch number 2 will elect the root bridge. Clear? Now, the first question, this is the very important question, and then this is the very simple question. How switch number 1 tells its own bridge ID to switch number 2 and how switch number 2 will tell its own bridge ID to switch number 1. How? Are you guys getting my point, what I am telling? I'm audible.
Hello.
Yes.
Okay. So what is my question? Switch number 1 and switch number 2. I told you now on the basis of what? On the basis of bridge ID, right? Na? On the basis of
Sure.
bridge ID, root bridge election will perform here. But the question is how switch number 1 will share its own bridge ID to switch number 2 and how switch number 2 will share its own bridge ID to switch number 1. Fine. So guys, what is the answer? Answer is basically definitely if switch number 1 is sharing something to switch number 2 and switch number 2 is sharing something to switch number 1, there will be a message. There will be a message. And what is the name of that message, guys? BPDU. So by the help of BPDU, switch number 1 and switch number 2 will share its own bridge ID. Guys, what is BPDU? BPDU stands for Bridge Protocol Data Unit. Bridge Protocol Data Unit. So basically, switch number 1 and switch number 2 share its BPDU. BPDU is types of message, and by the help of BPDU, switch number 1 and switch number 2 will share its own bridge ID.
We have to enable this BPDU or it is by default enabled?
Yes, it is by default. Fine. Now, content of BPDU. I just tell you something more information about the BPDU. Please remember this one. There are some content in the BPDU. What will be the content? First is version. Version field tells you about the it is CST, PVST, RSTP, which one. Fine. Now, type field. Basically, there are two types of BPDU. First is config BPDU and second one is TCN BPDU. Fine. So by default, there is a config BPDU. Fine. So just for your information, just remember there are two types of BPDU. First is config and second one is TCN, topology change notification. Fine. Next content inside the BPDU, that is guys flag. Fourth one is root bridge ID. Root bridge ID. Fifth one is sender bridge ID. Sixth one is root path cost. If you guys write this one, it is better. Root path cost. Then port ID. Then hello time. 10 forward. Delay time. 10th point I already written. Maximum age time. Message age time. Okay, so basically now these are the 12 things you will see in the BPDU packet. Fine. And one more
Last
thing.
one is what? Below
Message
hello
age.
time, what is it?
Maximum age time. Maximum age time, and that is message age time.
No, the 7, 8 hello time, then forward.
Forward delay time, maximum age time, or message age time. And one more thing, size of BPDU is 35 byte. Size of BPDU will be, guys, 35 byte.
Maximum age time and message time.
Understand? Everyone
Size
written?
is 35 bytes, huh?
Yes. Okay. Now, very basic question here. If switch number 1 is sending the BPDU, what will be the source MAC and what will be the destination MAC? So please remember, source MAC will be switch 1 MAC address. It means A. Destination MAC will be multicast MAC address. Which one? That one which you are using in the DTP and VTP, if you remember, 0180 C2 00 and 4 times 0. Fine, that is the multicast MAC address. Clear, everyone? Written? Tell me, written na?
Yeah.
Okay. Now I am erasing this one. Okay. Now, let's suppose we have a two switch number 1 and switch number 2 is there. Fine, clear na? Let between switch number 1 and switch number 2 there is no wire. It means these switches are not directly connected with each other. So if these switches are not directly connected with each other, so in what is the name of that state, guys? The state is called disable state. Please remember this one. Which one, guys? Disable. Fine. When I connect the wire, suddenly both switches will move in which state? Block. Fine. In blocking state, switch will stay in some microsecond. Fine. And after blocking, suddenly it will move in which state? Listening state.
Okay.
Which state, guys? Listening state.
Sir, is this situation for both switches or switch one?
Both switches I'm telling.
Okay.
Fine. So let's suppose if switches move in the listening state, in this state, switch can receive the, no, not packet, that is BPDU. Switch can receive the BPDU as well as send the BPDU. And basically in receive the BPDU as well as send the BPDU. In which state? Listening state. After listening, one more thing. In listening state, switch stay for how much time? 15 seconds. Now, learning state. In learning state, what switch will do? Switch learn the source MAC address and make its CAM table. Switch learn its source MAC address and learn, and make CAM table. And in this state, switch stay also 15 seconds. And after learning, last one is after learning, switch will move in which state? Forwarding state. In forwarding state, switch starts actively forward user's data frame. I hope till now you guys understand.
In the this one learning state, it will learn and it will update the CAM table.
Yes, in learning state, it learns the MAC address and it's update the CAM table. Last one is forwarding. In forwarding state, which actively send the data frame. Written, can I erase it then, guys?
Yeah.
Sachin, done?
Yes, sir. Yes. Okay.
Okay. Now, switch number 1, switch number 2, MAC address is A, MAC address is B. So I told you, we are talking about the listening state. Okay. So I told you in listening state, switch number A, switch number 1 send the BPDU and switch number 2 also send the BPDU. Tell me yes or no. Yes, na? Are tell me yes or no. Yes, na?
Yes. Yes.
So if switch number 1 and switch number 2 is sending the BPDU, I told you inside the BPDU there is a content na root bridge ID. I think you guys already
Yes.
written na
Yes,
root
yes.
bridge ID. Inside the BPDU there is a root bridge
Root
ID.
bridge
Fine
ID.
na? So my
And this-
question is, let's suppose both switches is in the listening state and both switches is sending the BPDU. So in the first time, what will be the root bridge ID? My question is, in listening state, when switches are exchanging
bridge ID.
its BPDU first time, then what will be the root bridge ID?
The lowest means it will be 0.
See, guys, tell me one thing. If you are on home, fine. Let's suppose na you are a big brother. Okay, you are big, and let's suppose na you have two younger brother. So when if you are on the home, you think like this na, you are the boss. Only you are the boss.
Yes.
Tell me. Everyone is thinking like this. Yes, I am the boss.
Yes. Yes.
Understand, everyone? So see, actually what will happen? So if switch number 1, so if switch number 1 and switch number 2, it in the listening state, so both switches, switch number 1 and switch number 2, both will share its BPDU at the first time. Fine. But try to understand, at the first time, both switches, switch number 1 and switch number 2, will think I am the boss. I am the boss. Getting my point? Tell me.
Yes.
So
Yes.
what will happen in the first time na switch number 1 and switch number 2, both switches will consider itself as a root bridge. Itself as a root bridge. It means switch number 1 is considering itself as a root bridge and switch number 2 also considering itself as a root bridge. Getting my point? Everyone. Are tell me, clear na? I told you by default what is the root bridge ID, guys? 32768 at plus MAC address. What is the MAC address of switch number A? A. So guys, when switch number 1 is sending the BPDU, switch number 1 is sending the BPDU, what will be the root bridge? Root bridge ID 32768 plus A. And B will share the BPDU, and in this BPDU, what will be the root bridge ID? 32768 plus MAC address B. Clear, everyone?
Yes.
Tell me. This is the root bridge ID of switch number A, and this is the root bridge ID of switch number B.
So what is
After
the reason this number has been selected?
Sorry,
3276. Why this number is only selected 32768?
this is the by default switch select. This is based in the iOS itself.
Okay.
This is fitted in the iOS.
So this is a
Fine.
fixed number. We have to just remember
Yes,
that.
fixed number. Yes. Now,
Okay.
one more thing. I told you, na, in the BPDU, there is a one more ID, sender bridge ID, if you guys remember. Right, na? What do you
Yes.
mean by sender bridge ID? Sender bridge ID means the ID of sender who is sending the BPDU. Clear, everyone? Sender bridge ID. So who is the sender, guys? Which one is the sender? Sender bridge ID will be 32768 plus A.
Yeah.
And who is sending this BPDU? Switch number 2 is sending the BPDU. So on switch number 2, what will be the sender bridge ID? 32768 plus B.
32768 plus B.
Understand, everyone? Now, third thing. I told you in the BPDU, there is a cost value as well, right now?
Yes,
So,
cost value.
if both switches, switch number 1 and switch number 2, both switches are considering itself as a root bridge. So please remember, when switches is in root bridge, so cost will be always 0.
0.
Cost will be 0. So guys, when switch number A is sending the BPDU, in this BPDU cost will be 0. And in case of switch number 2, cost will be 0. I
Cost
hope
of
you
what?
guys understand till now.
Cost of what?
Cost of path.
Cost of the path. Okay.
Yes, cost of the path. Fine. So it will be 0. So actually, na, this is called root path cost. Fine. It will be 0. Now, actually, na, we are defining cost like this. The total path to reach the root bridge. And right now, switch 1 and switch 2 both are considering itself as a root bridge. So cost is 0. Now, next is, guys, one more thing here. Sender port ID. Sender port ID. So basically, na, sender port ID is made up of two things. Port priority plus port number. Port priority plus port number. Getting my point? What is, guys? Sender port ID. Sender port ID. Sender port ID is made up of two things. Port priority and port number. Fine. Now, by default, port parity will be, guys, 128 by default. By default, port priority will be, guys, 128. And what is port number? Let's suppose if we have fast Ethernet 0 by 1. So this is called port number. One is called port number. Clear, everyone? Let's suppose this is fast Ethernet 0 by 1. This is fast Ethernet 0 by 2. So what will be the port ID? 128.1, and here port ID will be, guys, 128.2. Clear? Everyone tell me, you guys, I hope you guys understand till now. Clear? Okay. Next, source MAC address and destination MAC address. I already told you. Source MAC address.
double ali hai na?
Sorry.
Sorry.
Source MAC address will be A and destination MAC address will be multicast in both cases from switch number 1 and switch number 2. Fine.
Okay.
Now switch number 2 share its own BPDU with switch number 1, and switch number 1 send its own BPDU with switch number 2. It means now switch number 1 have how many BPDU, guys? 2 BPDU. First, on BPDU.
Yes.
And second,
And another is
switch 2 BPDU.
received BPDU.
Right now, switch number 1 has 2 BPDU. First, खुद का BPDU, and second one, switch number 2 का BPDU. Clear?
Yes.
Switch number 2. Switch number 2 have switch number 2 have 2 BPDU. First,
Two BPDU.
on BPDU, And second one is
Sender VPD.
switch one. Yeah, sender VPD. Clear na? Are tell me.
Yes.
Okay, just give me 2 minutes, guys. Okay. Sorry, guys. I'm audible.
Yes.
Okay. So, what I told you, switch number. Yes. So basically, what happened? Switch number one send its own BPDU, and switch number two send its own BPDU. Clear na? And when switch number one is sending this BPDU, and in this BPDU, these are the information. And when switch number two is sending the BPDU, these are the information. Clear, everyone? Any doubt till now? Clear na? Now, I told you how root bridge will elect on the basis of root bridge ID. Fine. So guys, tell me, when switch number one receive the BPDU from switch number two, it means now switch number one have how many BPDU? Two BPDU. It's on BPDU and switch number two BPDU. Then what switch number one will do? Switch number one will compare both root bridge ID. It means switch number one, its on BPDU is 32768 plus A. And switch number one is getting the BPDU from switch number two. And in this BPDU, what is the root bridge ID? 32768 plus
B.
B. Now switch number one will compare both bridge ID. So see na, priority is tie here. Tell me yes or no. This is tie na.
Yes, this is tie.
Now
Yes.
on the basis of MAC address, A and B, who's the smallest? This one, right na? Then switch number A will understand my BPDU, sorry, my root bridge ID is smallest compared to switch number two. Compared to switch number two, it means my root bridge is better than switch number two. It means I am the
Root bridge.
finally switch number two also match its own BPDU as well as switch number one BPDU. Then switch number two will understand, yes, my BPDU is not better than switch number one. Getting my point? It means I am not the root bridge in my topology here. Getting my point? Understand? Tell me yes or no. Are tell me?
Yes, sir.
Okay. Now, guys, there is a one question. Question is not that this is the interview question. I think anyone asked me this question. Question is how switch number two will inform. See, first of all, just tell me one thing. Switch number one, now understand I am the root bridge and elect itself as a root bridge. Fine. And switch number two, when switch number two match its on BPDU as well as switch one BPDU, then switch number two understand I am not the root bridge because my root bridge ID is not better. Clear na? Now the point is how switch number two will inform switch number one. How switch number two will inform switch number one that I accept you are the root bridge. How switch number two will inform switch number one that I accept you are the root bridge. Basic simple answer. When switch number one accept I am not the root bridge, then switch number two do not send the BPDU. Understand? So please remember, only root bridge after the election, only root bridge will send the BPDU. Not all the switches. Clear, everyone? After the election, only root bridge will send the BPDU and inform all the other switches. Fine. So,
But
Come
sir,
again,
now here we are taking only two switches. Maybe in this scenario we will have 9 or 10 switches. So how this comparison will happen?
how this comparison will happen? Wait, I will explain you this one as well, how election will perform there. Fine.
Okay.
But in this scenario, how switch number two will inform switch number one, switch number two stop sending the BPDU. Fine.
Okay.
Clear? I'm talking about the config BPDU. Fine na? Clear. Now, next scenario is one more thing I just want to tell you. For example, if we have topology like this, switch number one and switch number two, and there are some PCs. There are some PCs. Fine na? This is fast Ethernet 0 by 0, 0 by 1. Switch number 1 send the BPDU. Tell me yes or no.
yes.
Switch number 2 also send the BPDU. Fine, na? Are tell me yes or no?
Yes.
Now, at the starting stage, both switches will understand or itself as a root bridge. It means both switches send the BPDU. Tell me yes or no? Yes, na?
Yes.
And after that, after the election, which one will become the root bridge? Are tell
Yes.
me right now?
Yes. Yes.
Now, after the election, only root bridge will send the BPDU. Tell me, after
Yes.
the election, only root bridge
Root
will
bridge
send the
will send
BPDU.
the
But
BPDU.
remember one thing, root bridge will send the BPDU through all the interfaces, no matter it is a trunk or access. It means switch, let's suppose this is the trunk. So switch one will send the BPDU through this interfaces as well, through this interfaces as well. Getting my point, everyone? This is
Yes.
the point I want to tell you. Fine.
Okay.
So when switch number 2 understand that I am not the root bridge, then switch number 2 stop sending the BPDU.
BPDU packet.
Only switch number 2 listen the BPDU. Only switch number 2 will listen the BPDU. Fine. And if let's suppose switch number 2 do not accept and do not receive the BPDU, then what will happen? If switch number 2 do not receive the BPDU, then switch number 2 will think my neighbor switch number 1 is now dead. Now dead, and switch number 2 consider itself as a root bridge then. Understand everyone? Are tell me clear now?
Yes, sir. Yes.
Okay, one more thing, switch number 1 is sending the BPDU through access link as well. Fine. And please remember this port always be in forwarding state, because switch number is, if switch number 1 is sending the BPDU through this link, it means switch number 1 is not receiving any BPDU here from PC number 1, because PC do not generate any BPDU na. So it means this switch understand or think कि at this interface there is some end users. There is
Yes.
some end users and there is a no chance for loop. So that's the reason this interface always be in DP, you can say, or you can say in forwarding state. In forwarding state. Clear, everyone? Okay.
Yes.
One more thing. Let's suppose if we have a topology like this. If we have a topology like this, find A, B, C. MAC address of all the switches is A, B, and C. Clear na? Now just tell me one thing. Guys, tell me one thing, the basic thing. Let's suppose, are you guys are thinking like this? Switch number A is sending the BPDU to B, and B is forwarding that BPDU towards C, and C is forwarding that BPDU towards A. Are you guys are thinking like this or not?
Yes. It may also send.
No. My question is,
Yes,
see what I'm telling.
Yes, we are
If
thinking.
you guys are thinking like this, then please let me know. Switch number 1 is sending the BPDU to B, B relay this BPDU towards C, and C relay this BPDU towards again A. For election.
No. For election. No, sir. No.
No. Yes, please remember this one. No, never. Always election will perform on the single segment. Fine.
In two switches. In
Yes.
between two
So
switches.
switch number 1 send the BPDU to B, B send to A,
Plus,
B send to C, C send to B, A send to C, and C send to C, and accordingly election will perform. Okay, so do not think like that. Fine, clear? Are tell me, clear na? Okay, cool. Now, if let's suppose if we have a topology like this. Tell me.
Zeta out Ridgewood.
Tell me, guys.
Sir, come again, the question.
Okay. I think you guys not understand the question. Okay. See, A, B, and C. For example, if we have a topology like this, first of all, understand this one. Switch number A send its BPDU towards B and B send its BPDU towards A.
Towards
Fine.
A,
And in
yes.
this BPDU, there is a root bridge ID. Fine. And on the basis of root bridge ID, switch A will become the root bridge. Tell me yes or no.
Yes.
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 Right, na?
Right. Right.
32768 plus A and 32768 plus B. It means A has the better bridge ID, na?
Yes.
So
Yes.
A become the root bridge and switch number B stop sending the BPDU from this interface. Fine.
Okay. Yes. Fine.
Now between A and C, A send the BPDU, C send the BPDU. A has a better bridge ID, na?
Yes.
So this
better
is the root
bridge.
bridge and C stop sending the BPDU.
Yes.
Right? Now between B and C,
Both share the BPDU packet,
hmm,
and which is small in this B MAC address is smallest. In between, B will be root bridge
okay.
between two switches, B and C.
Okay. So guys, see, basically na, in this case, what will happen? B send its BPDU, C send its BPDU.
Yes.
Clear na?
Yes.
So when C got the BPDU from B, then C thinks like that, कि I have 32768 plus C and here 32768 plus B,
B.
right na? It means B has a better BPDU, right na? Or better sender, right na?
Yes.
So C think B will be
C
the
is
root
the
bridge,
root
but
bridge, yes.
at the same time C is directly connected with
A,
as
yes.
well. Fine.
Yes.
So C
Yes.
already got the better BPDU from the A as well. So C understand ki
Automatically understand
let's
that A
suppose
is
C
the
receive.
root bridge.
Now you can say na ki on C how many BPDU C have? 3 na. 1 32768 plus B. Second one itself 32768 plus C, and third one C directly connected with A as well. So 32768 plus A. Clear? Tell me yes or no. Yes na?
Yes. Yes.
So
Yes.
so when C compare all the bridge ID na, so then C will finally calculate na ki switch number A has the better bridge ID. So finally I am thinking wrong. Switch number B is not the root bridge. Switch number A is the root bridge. Understand?
Yes. Yes.
Tell me, clear na?
Yes. Sir.
So,
Clear.
okay. Now my question is, so in this scenario, how switch number C will understand ki switch number A is the root bridge? First of all, election will
it
perform
can,
between A and B.
yes.
Tell me, yes or no? A
Yes.
send the BPDU, B send the BPDU, and finally A will elect as the root bridge, and B stop sending the BPDU. Tell me yes or no?
Yes.
Now,
Now C can't understand that which is root
now,
bridge.
see the
C,
concept.
yes. Yes. C can't understand
A
which
send
is
the
the root
BPDU,
bridge.
fine.
Yes.
At the starting stage, A send the BPDU, B
Yes.
send the BPDU. Clearly, yes or no?
Yes.
Yes. And A has two BPDU. First, 32768 plus A means itself BPDU, and switch B 32768 plus B. Right or wrong? Right?
Right.
Now, on B has two BPDU, 32768 plus A and 32768 plus B. Now, switch number B will understand na ki I do not have better bridge ID. Switch number A has the better bridge ID, right? So switch number A become the root bridge. Tell me yes or no. Yes.
Yes. Yes.
So
But
if
what
switch
about
number
C?
A is the root bridge, it means who can send the BPDU now only? Only root bridge will send the BPDU. I told you, right? This is not the root bridge now. So it means we do not send the BPDU through this interface. Tell me yes or no.
It means B will be switch B will be bypass in this condition.
Okay. Okay. But
No,
see,
I'm asking.
Switch number B also send the BPDU here and here. And if you perform the election here between B and C, definitely C will think na ki B is the root bridge.
Yes.
But actually, who is the root bridge? A. So I
Yes.
hope you got my question ki how C will understand switch number A is the root bridge in my topology because switch number B is non-root bridge, right na?
Yeah.
Between if you perform the election between A and B, so B is the non-root bridge, and if this is the non-root bridge, I told you it do not generate the BPDU,
BPDU
and
packet.
I told you here in this topology as well, when switch A send the BPDU, this BPDU will reach on B, and B do not relay this BPDU towards here like this. Do not think like this, right now. So if this is not happening here, then how switch number A bridge ID, sorry, switch number A BPDU will reach on switch number C? This is my question. Who can tell me the answer?
In this condition, switch B will forward the BPDU BPDU packet which belongs from switch A.
Okay.
मतलब जो बी स्विच है वो अपना खुद का बीपीडीयू पैकेट ना भेज के स्विच ए का बीपीडीयू पैकेट सी को भेजेगा।
Okay.
ऐसा हो सकता है
वही तो मैं पूछ रहा हूँ.
डायरेक्टली।
So guys, see, I told you na. So see, I just concluding the things here. So I told you, let's suppose at the first time when switch number A is sending the BPDU, fine. This BPDU and switch number B is sending the BPDU, fine. First time, this BPDU will reach on A. A do not forward this BPDU like this, and B do not forward the BPDU like this. Fine. I am talking about the first time. Fine, na? But here try to understand what will happen. So please remember one line about the in election when BPDU will relay or when BPDU will not relay. It means when switches will relay the BPDU and when switch will not relay the BPDU. Let's suppose if we are talking about the first time election, it means when root bridge is not elected. So at that time your BPDU will not relay. And when election will done, it means when switches already know this is my root bridge, then after switches will relay the BPDU. I hope you guys understand this concept now. Clear? So see what will happen. I am concluding here, guys. So please focus here. So for example, if we are talking about switch 1, switch 2, switch 3 like this, so it means switch number A, B, C, all the three switches, here election is not performed. Switch number A send the BPDU, B send the BPDU. It send the BPDU, it send the BPDU, it send the BPDU, it send the BPDU. Fine. So this is the first time. It means here right now, root bridge is not elected. Tell me yes or no? Yes, na? So if root bridge is not elected here, it means switch number A send the BPDU to switch number 2 and switch number 2 send the BPDU to switch number 1. That BPDU will not forward it like this, or that switch number 2 do not relay this BPDU like this. Fine. This is the first condition. Now, second condition, A, B, C. Switch number A send the BPDU, B send the BPDU. And when both switches send the BPDU, switch number A will become the root bridge and this will become the non-root bridge. Now, switch B send the BPDU, C send the BPDU. C think who is the root bridge? B, but actually this is not. But after some time, what will happen? See na, B already know who is the root bridge? A. B already know who is the root bridge? A. Now I told you, only root bridge can generate the BPDU. A generate the BPDU after 2 seconds. This BPDU reach on the B. Now B will relay this BPDU towards switch number C, and finally switch number C will understand A is the root bridge. I hope this concept is now clear.
Yes, sir.
Clear ना?
स्विच भी खुद को बाईपास कर देगा।
यस, देखो जब स्विच बी को पता चल जाएगा कि मेरा रूट ब्रिज ए है, तो उसके बाद वो आगे रिले करेगा। अगर स्विच बी को पहले वाले पॉइंट में स्विच बी को पता नहीं था कि ए मेरा रूट ब्रिज है, क्योंकि उस टाइम इलेक्शन हो ही रहा था, तो उस केस में स्विच कभी भी उसे रिले नहीं करेगा। क्लियर? स्विच विल रिले द बीपीडीयू ओनली आफ्टर द इलेक्शन। अंडरस्टैंड?
यस सर।
Everyone, Guys, are you guys there?
Yes, sir, understand.
Buddhika, are you there? Tell me. Okay, clear. Now, if it's clear, then I have one question. This is the final question. And if you answer this question, I hope then you understand the election part. Let's suppose if we have a topology like this. A, B, C, D, E. How election will perform?
Election will be in two switch in between two switches.
Okay, so see, first of all, election will perform between A and B,
Between A and B, yes.
right? A will become the
Root bridge, okay. In
root
this
bridge.
condition, root
And
bridge.
this is
Non-root bridge.
between A and C. Who will become root bridge?
A is root
A
bridge,
become the root bridge, and this is
non-root bridge.
clear na? Understand na?
Yes.
Now tell me between
Now between B and
B and
D,
D.
B and D, D think that B is root bridge.
Yes, B send, D send, and D think B is
D
the
think
root bridge.
B is the root bridge.
Right na? Now between C and E. C is the root bridge.
C is the root bridge. E think C is the root bridge. Okay.
Okay. Now
Yes.
tell me.
Now D and E will understand that I am not root bridge. So
Okay.
ultimately, switch A is root bridge. Declared the switch A is the root bridge.
See,
Answer, जैसे
so see na
B
on
and D
on
में
B
जब
you are
election.
writing on B you are writing this is the non-root bridge and root bridge both na.
Yes.
So this is not possible na.
Okay.
Either
Yes.
B
Yes.
will be the root bridge or either non-root bridge. This is not interface based ना. root ये कभी भी interface based नहीं होता.
Then switch A will generate again BPDU packet. That packet directly goes to switch D.
Yes, exactly. So after this election, after the first time when switch number B already know who is the root bridge A,
Yes.
C already know who is the root bridge A. Fine. After
Yes.
that switch number A generate the BPDU. After that A generate the BPDU. Then after we will forward this BPDU towards D and it forward towards E. And finally D also understand who is the root bridge A and E also understand who is the root bridge A.
Is the root bridge. Yes.
Understand? Clear?
So this anything related to VLAN here? I mean, within
No.
the VLAN you have this? No, it is
No.
it is a global.
Not global. See, basically, na yes, you can say this is per VLAN.
Exactly.
Or let's
This is
suppose
what
if
I was
we are
asking.
talking about the VLAN number one by default. Okay. So let's suppose this is possible for every VLAN. Root bridge will be different. It is possible.
Exactly. Yeah. Right.
Okay. I hope you guys understand what will happen. Okay. So please remember one thing.
So every
Who will
VLAN,
know who is the root bridge? So please remember. So that switch which is near to the root bridge. Who is near to the root bridge.
So this all information when you are watching it, so we have to first check in which VLAN we are,
Yes.
and it will work
Yes,
accordingly.
you are in which VLAN. Yes.
Okay.
Now, next topic or next point is port role. So basically, in STP there are 3 port role. First is DP, second is RP, and third one is alternate, or you can say block. Fine. So basically, there are three types of port role in STP: DP, RP, and alternate. If anyone asks you, define a root port, how can you define, guys? A port from which we can reach the root bridge in least cost. In least cost, that is called a root port. Fine. So cost is predefined. Predefined. Cost is predefined. For example, if you are using 10 Gbps, then cost will be 2. For 1 Gbps, cost will be, guys, how much? 4. For fast Ethernet, cost will be 19, and for Ethernet, cost will be 100. So remember this one.
Okay.
So basically, so do not calculate this one. This is something which is already fitted or defined in the iOS of the switches. Like na, AD number, AD value, if you guys know, router calculate na AD value. Fine. So router do not calculate the AD value. It is also fitted in the iOS. The same thing in case of STP cost. Cost is already fitted in the iOS. For example, if you are using OSPF,
what
AD
is AD
value is by
value?
default 110 na. If you are using OSPF by default, AD value is 110. So there is no formula to calculate the AD value. Similarly, there is no formula to calculate the cost. Fine. So in some book na, you see this line. Cost is calculated on the basis of bandwidth, and this cost is pre-defined in the switches. When you read the Cisco book now, you will see this line there. Okay, understand? So if anyone asks you, can I change the cost? Yes, you can change the cost. Can I change the AD value? Yes, we can change the AD value. Clear, everyone?
So what is the AD value?
Sorry?
AD value, what
What
is it?
is the
AD value, this is the, you can say in routing protocol, now I will explain you the AD value. AD value means administrative distance. It means, let's suppose if you have a 2 path to reach the destination, how much you can trust on that path, that is defined by the AD value. आप किसी path पे कितना trust करते हो, ये चीजें define होती है by the help of AD value. Clear? Understand? अरे tell me.
When we'll go to the routing, we will understand more in depth.
Yes. Okay. Give me 2 minutes. I just use the restroom. Do one thing, guys. If you guys need, you guys can also take 5 minutes break. Fine.
Okay. All right.
Hi everyone. Am I audible? Guys. Okay, so I told you about the root bridge, right now? I hope now you understand how root bridge will elect. Clear now?
Yes.
Now, after the root bridge, I told you there are some port role. There are some port role, right now?
DP,
What is that
RP.
port role? DP,
BP, RP,
RP, and
block.
block. Right now? Okay. Now, see the scenario. For example, if we have topology A, B, and C. If we have topology like this. Clear? Understand?
Yes.
So if we have a topology like this, it means at the first time every switches will exchange the BPDU. Tell me yes or no.
Yes.
On every link, right now, on this link, this link,
Yes.
this link,
In
every switches will exchange the BPDU, and finally switch number A will become the root bridge,
root bridge.
and these
Yes.
are called non-root bridge.
Root bridge.
Clear na? Understand? So
Yes.
till now only root bridge is elected. Okay na? Port role is not decided. Only
Port role.
root
Yes.
bridge is elected. Port role is not decided. Tell me.
Yes. Not decided.
Fine. So now after the election, I told you na ki only root bridge will generate the BPDU. Tell me yes or no.
Yes.
Right na? So after let's suppose election is done and switch number A become the root bridge. So now only switch number A is sending the BPDU. Tell me yes or no. Yes, na?
Yes.
Are tell me clear?
Yes. Yes.
Now see the scenario. A, B, C. If switch number A is the root bridge, fine.
Okay.
Switch number A is sending the BPDU. So inside the BPDU, root bridge ID will be 32768 plus A. Clear?
Yes. Clear.
Fine, na? This is the root bridge ID, na? 32768 plus A. And
yes.
after the 32768 plus A, what will be the value? Tell me.
32768 plus A.
Okay. See, I just clear one thing. If switch number A is sending the BPDU, basically, na, in this BPDU, I am writing the 3-4 content. I am not writing the whole content here. Okay. I am writing only the basic thing. Okay. One more thing. One more thing. Before I start the root port, na, okay. So please remember this sequence. First of all, switches will check the root bridge ID. Fine.
Okay.
After root bridge ID, switches will check the cost value. Fine. Third one is after cost, switches will check the sender bridge ID. And after this, switches will check the port ID. So please remember this sequence always. Fine. Why I am writing this sequence? When any switches receive any BPDU, na, first of all, switches check the root bridge ID. If on the basis of root bridge ID, switch is able to perform or switch is able to take action, then on the basis of root bridge ID, switches will take. If root bridge ID will tie, then switches will check second thing, cost. Fine.
Cost.
And if cost will tie, then switches will check sender bridge ID. And if sender bridge ID will tie, then switches will check the port ID. Fine. At the first time, switches do not check everything. Switches will always check by this sequence. यही sequence में check करेगा switches always. Clear है इतनी बातें?
Yes.
अगर पहला एक्सेप्ट नहीं हुआ तो अदर थिंग्स विल नॉट गेट
Yes. अगर पहला टाई हो गया तो फिर वो नेक्स्ट की तरफ बढ़ेगा.
अगर नहीं हुआ तो,
और अगर ना हुआ तो मतलब कोई ना कोई इसमें से कोई ना कोई तो हो ही जाएगा ना, ना कुछ हुआ तो लास्ट तो ये पोर्ट आईडी तो हो ही जाएगी.
Okay.
Clear? Now, see, this is the switch number A. Switch number A generate the BPDU. In this BPDU, first of all, guys, root bridge ID. Tell me the root bridge ID.
76
32768 plus A. Clear na?
Yes.
Now,
This is root bridge
cost.
ID.
This is the
Cost.
root bridge. So cost will be
Cost will be
0.
0.
Now, sender bridge ID. Sender bridge ID means who is sending. Which number A is sending. So 32768 plus A.
A.
Fine na? Tell me.
Yes.
Now let's suppose this is fast Ethernet 0 by 1 and this is 0 by 2. This is
Port
0
ID.
by 1, this is
Port ID.
0 by 2, this is 0 by 1 and this is 0 by 2. Clear na? Now,
Okay.
what is the port ID?
0 by 1.
If switches is sending through this interface, then 128.1. Clear na? Tell me.
Okay, okay, yes.
And if switch number A is sending this BPDU through two interfaces, na? Through this one and
Yes.
through this one. Tell me, yes or no? Yes, na?
Yes.
So everything will be same, only one difference. What will be the difference? Tell me. I just copy this one.
Ethernet port number.
Changing in
Port ID. Port ID will be
port
different.
ID will be changed.
Yes. So see, switch number A is sending the same BPDU here 32768 plus
A.
A. Cost will be 0. Sender bridge
Cost
ID
will be
32768 plus A. Port
A.
ID will be 128.2. Are clear na everyone?
Yes, yes, yes.
Now, switch number A forward this BPDU towards switch number B. It means switch number B receive this BPDU here on 0 by
Yes.
1. Tell me 1.
0 by 1.
Tell me.
Yes.
Clear na?
Yes. Yes.
Okay. So first of all, we are discussing about the switch number B. Okay. Then we will discuss about the switch number C. First of all, I just explain you how switch number B will calculate the root port. Fine na? Then after we will
Yes.
discuss about the switch number C. So see guys, switch number B receive this BPDU from A on which interface? 0 by 1. This
1.1.
BPDU. Right now, exactly this BPDU. Fine. Switch number A send this BPDU towards switch number C. Tell me yes or no.
Yes.
Hello.
Yes. Now, what switch number C will do? Switch number C receive this BPDU on which interface? 0 by 1. Now, switch number C will relay this BPDU. Tell me yes or no. Yes, na? Switch
Yes,
number
yes.
C will forward this BPDU towards switch number B. But after some modification, what will be the modification? Root bridge ID. Root bridge ID will always be same. 32768 plus A.
A.
Fine. Cost will be, guys. Tell me.
0. 0.
Tell
Cost
me
will be
cost.
0.
Cost.
Cost
So
will be 0.
Why 0?
No.
Root bridge. This is the root bridge. Root bridge is sending the cost 0. When switch number C is receiving the cost on this interface, and if switch number C is forwarding here, then what will be the cost?
1.
Cost will be 1.
This is fast Ethernet.
Fast Ethernet cost will be 19.
19 for this link, and for this link 19 will be here. The total cost will be, guys, on this interface.
Yes, 19,
38.
or this 38.
Now
38.
after the cost, sender bridge ID. What will be the sender bridge ID? It means now who is sending this
3276.
BPDU? Switch number C.
Switch.
So
C,
32768 plus C.
8 plus C.
Fine. And priority will be 128.2. 2 na, this is 2. So 128.2. So this BPDU will reach on where? Tell me. This BPDU will reach on switch number B here.
Switch B.
Yeah.
Yes.
Now what switch number B will do? Switch number B will compare this BPDU as well as this BPDU.
Yes.
So when switch number B will compare, first thing, root bridge ID 32768A. Tell me yes or no. Yes na? And
Yes,
32768A means root bridge ID is tie.
Tie.
Second is
Cost is
cost.
tie.
Cost is on this interface,
Right.
cost is 0, and on this interface, cost is 38.
Okay, yes.
And always
38.
lower cost
Lower with the
will
root bridge.
prefer. So it
Prefer,
means
yes.
switch number B receive better BPDU on which interface? 0 by 1. 0 by
Yes.
1. So this
1.
port will become the root port. I hope
Okay,
everyone
RP.
understand how root port is elected here. Clear?
Yes, yes.
I will explain you the different scenario as well when cost will be tie. Okay, now guys tell me for this interface. Sorry, for switch number C,
Sheet
you
number
guys can
C,
calculate by
0
itself.
1.
I hope. Switch number C receive 1 BPDU here and 1 BPDU here. Tell me yes or no.
Yes.
So on this interface, first of all, root bridge ID 32768 plus A here as well, and 32768 plus A here as well. It means this is tie.
This is
Now on this interface, switch number C receive cost 0, and here switch number C receive cost 38. Tell me yes or no.
yes.
Yes, na?
Yes, yes.
Array
In
on this
condition.
interface, cost will be
Same.
0, na?
0.
And
here
here
is
switch
38.
will receive
38.
cost 38.
38.
So finally this will prefer, and finally this will become the root port.
Root
Clear?
port.
I hope you guys understand how root port is elected.
Elected. Yes. Yes, sir.
Array tell me clear, na?
Yes, yes.
Okay. So this is the way how we are calculating the root port. Okay. In tomorrow classes, guys, I will explain you how
RP.
root port is elected when cost will tie. Cost will tie. Understand na everyone? For example, switch 1, switch 2, switch 3, and switch 4. Like this. Fine. So for example, you can easily calculate this will be the root port, and this will be the root port, and this will be the root bridge. Right na? But what about this switch? This switch received the same BPDU here and the same BPDU here. Right na? So on this interface 32768 plus A, and on this interface 32768 plus A. And what will be the cost? 19 plus 19 on this interface 38, 19 plus 19 on this interface 38. Tell me yes or no.
Cost.
Then it means cost is also tie. Then how switches will calculate? Tomorrow we will discuss this concept further. Clear?
Okay.
Everyone?
Yes.